All right, gentlemen, I hope you enjoyed your beautifully weathered weekend. Let's take a look at some, just tying up some loose ends with some of the stuff we were talking about with trig functions and radians. So just a little review. These are the things we know. Coterminal angles, right? So as it says here, coterminal angles are the ones that start and end in the same spot. We know that. They're basically just multiples or rotations of 360. Right, so we've done that a couple of times. We know how to convert radians to degrees and vice versa. And we know that radians to degrees would be multiplying by pi over 180, and vice versa would be multiplying by 180 over pi, right? And we know that because whatever you're converting to is the thing that's on top. That's how I remember it. We know which quadrants have positive trig functions by all students take calculus, right? So we have our little coordinate plane over here, and this is all functions, just the sine functions, just the trig functions, tangent functions, and just the cosine functions and the reciprocals. We know the reciprocal functions, right? So we had talked about that from, I think, one of the first classes. For sine, that's cosecant. For cosine is secant, and then for tangent is cotangent. So we have all of our reciprocals, and they have opposite relations. So sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. We know that. All right, cofunctions, the thing we did not get up to on our Zoom day. These are functions that are complementary to each other, meaning they add up to 90. And there's very special things that happen to you. You may have observed it when we looked at sine and cosine. So let's take a look at that. Right, and again, these are different than coterminal. They're not the same. Coterminal starts and ends in the same spot. These have to add up to 90. It should not be surprising that sine and cosine, right, they have the word co-complementary. Cosecant and secant, they have the word co, and then tangent and cotangent. So the co in those functions means complementary. So let's take a quick look at how to, of sine and cosine, and it should make a little bit of sense here. All right, so 0 degrees is 0 radians. We know that because 0 times pi over 180 would be 0. 0 or 30 times pi over 180 would be pi over 6. So that's 30 degrees, pi over 6. 45 degrees is theta, or is 45 times pi over 180, and that is 45 divided by 180 is 1 over 4. So that's pi over 4 is 45 degrees. 60 degrees is, and if we see that, right, 60 times pi over 180 would be 60 over 180, so pi over 3. And then 90 would be pi over 2, right? So I did it a little fast, but if you need to slow this video down just to take a look at that, it should we should get better at converting. 30, that's pi over 6 because it's 180 on the bottom. 45, pi over 4. 60 is 30. 90 over 180 is pi over 2, or 1/2, right? All right, so we should have these functions memorized. I'm going to do sine in red and then cosine in green, right? So sine of 0 is 0. That's where sine starts. And then sine of 30 is 1/2. If we do our 30, 60, 90 triangle. Sine of 45 is 1 over radical 2 to a 45, 45, 90 triangle. Sine of 60 is radical 3 over 2. And then sine of 90 is 1. Right, because it's opposite over hypotenuse. The opposite is the hypotenuse. Okay, now if we remember, cosine starts at 1, and that's where sine ends here. Sine ends at 90 at 1. Cosine of 30, right, is radical 3 over 2. If we draw our 30, 60, 90 triangle, we'll do that quick at the bottom. 30 degrees and 60 degrees. 1, radical 3, and 2. If we look here, sine of 30 is opposite over hypotenuse, 1/2. If I do cosine of 60, it is adjacent over hypotenuse, right? So cosine of 60 is 1/2. So it does kind of make sense that they are, right? Because if we're looking at the same triangle, 30 degrees is opposite over hypotenuse, and this is adjacent over hypotenuse. And then if I were to do, if I do a 45, 45, 90, they're both the same because it's a right isosceles triangle, and then cosine ends at 0. And if we look at our graph, right, sine starts at 0, goes up, down, and cosine starts at 1 and goes like this. Like this. Okay. So it should kind of make sense that we see, this is a half, this is a half. This is 3 over radical 3 over 2, this is radical 3 over 2, and this is the same. Right? And if we think about the triangle, it should kind of make sense. These are complementary. Every 90, they're opposite each other. So we can kind of go like this. All right, sine of 60, well, what is that equal to? Well, the equivalent would be cosine of 30. Right? We just kind of saw that above, where they are equivalent. Cosine of pi over 3, well, what is pi over 3? Pi over 3 converts to times it by 180 over pi, and that's 60 degrees. And that's the same as sine of 30 degrees, which would be pi over 6. Pi over 6 is 30 degrees. Right? I'm doing a little bit of the calculations a little bit fast, but if we switch it to degrees, it should be straightforward for us to be able to understand that they have to add up to 90. It's a little bit harder for us to do it with the fractions, but if we just switch to degrees, we do our math, and then we switch it back. Cosecant, what's that going to pair up with? Secant. They're complementary. Well, what's pi over 4? That's 45 degrees. And to get back to 90, I do 45 degrees again, right? Secant and cosecant would be the flips of sine and cosine, and 45 degrees they are the same right here. Cotangent, which is going to match with tangent, pi over 6 times it by 180 over pi is going to give me 30 degrees, which means this has to be 60 degrees. And turning 60 degrees into radians, multiplying it by pi over 180 would give me pi over 3. Right? And again, I did those calculations a little bit fast. You could always slow down this video or look back to it, but we know how to convert from radians to pi, and eventually these will kind of become memory to us. So just for now, right, degrees to radians is, right, multiplying it by 180 over pi, and then radians to degrees is multiplying it by pi over 180, right? So did those calculations a little bit fast, but like I said, you just do the multiplication. I kind of picked simple numbers there. Quadrantals. Right now, the only thing we don't really know how to find the value of is what happens when we do sine of 45. I could do that. Cosine of 150. That I can do. What happens if we get like cosine of 180? What do we do with that? Right, so there's a couple of different ways to remember it. Sine refers to your y values in like a unit circle, right, if we think about that, and cosine refers to your x values. That's how some people remember it. Other people just look at the graphs of sine and cosine and remember that sine starts at 0, and cosine starts at 1. Right, and we kind of saw that in our graph that they're like just a little bit off, and sine starts at 0 and cosine starts at 1, and we kind of saw that up here too. Okay, all right, so again, we'll fill out our little table. Different now, I'm doing 0, 90, 180, 270, 360. This table had 0, 30, 45, 60, 90. Right, so this was only up to 90 degrees, but similar idea. Let's convert everything to radians so we have a really nice reference point. Okay, obviously 0 degrees is 0 radians, that we know. So I'll keep these in red, actually. 0 radians. All right, what's 90? We just did that up above. Times it by pi over 180, so it's pi over 2. Now, think about this. 180 times pi over 180 is just going to give me pi. Okay, 270 times pi over 180. right? So what is 270 over 180 should be 3 over 2. So that means this is 3 pi over 2. 360 times pi over 180. We can see that 360 pi over 180 is 2 pi. Again, calculation's a little bit fast, but we know how to calculate from degrees to radians. I'm just doing it a little bit quicker, just for sake of time. All right, so now the coordinates, right? If we think about 0 degrees, if we think about that on a coordinate plane, I do a little one down here, right? 0 degrees on, and if I had a unit circle in here, right? 0 degrees would be if I just went like this right here. And that is the point 1, 0. I go to the right one, and I don't go up or down. At 90 degrees, I go up, I go to the right or left, nothing, and I go up 1. So there's my coordinate for 90 degrees. At 180 degrees over here, I'm at negative 1, 0. Right there. And then if I go 270 degrees, we can kind of see here, I go to the left or right, none, and I go down 1. And there's my 0, negative 1. And then for 360, I'm back over here. So then it restarts. I'm back again over there. Okay, so we see our coordinates, and they match our unit circle, right? So that's what I mean when I said right up here, we remember the coordinates with where the trig function intersects the axis on the unit circle. So that's a reference. If you're good at the graph, you can kind of picture it in your head. This should be helpful. If not, and we'll see it here, sine is the y values, and cosine is the x values. Right? So they're kind of the same thing, but just as a reference, sometimes we like to to draw the picture too, since it is still new to us. Okay, so now let's just kind of fill out this table with sine and cosine to start. Those are our initial ones. So with sine, right, and if we remember that those are our y values, right, what's the y value in this right here? 0. Where does sine start? In our graph, sine starts at 0. That helps me remember that. Where does cosine start? Cosine starts at 1. That's where it starts, and there's my x value. 90 degrees, straight up. Right? Here's my picture, straight up right here. Right? Sine is my y value, so I go up to 1. Cosine is my x value. Now right next to here, just for reference, this is y, and this is x. And you can kind of see it's just going to fall exactly from these ordered pairs every single time, right? And then the other way to think about it would be, to know where it starts and to know like what's the pattern of sine. So sine starts at 0, it goes up to 1. Right? So we know what sine does. Sine starts at 0, it goes up to 1, down, up, down. Right? So it's here, 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 here. Cosine starts at 1, goes down, up, down. Goes to here, goes to here, goes to here, goes to here. Right, so they're just one shift over of each other. Oh, I hate when this happens. There we go. Okay. All right, so if we think about the graph or we think about the unit circle, we kind of get the same thing. But again, just to reference the unit circle and the y value, here, sine is my y value, which is 0. And if we look here, it's going all the way over here, 0. My x value is negative 1. With 270, we're down here. My x value is 0, and my y value is negative 1, right? And you see how they're always off. The one's here, then it's here, then it's here, then it's here. 0, right? And that's because they're just one phase shift off from each other. So now, at the last one, my x value is 1 and my y value is 0. So these exactly come from my x and y values from my coordinates, and those match my unit circle. It also matches the little graph I have down here, right? This is 0, 0. This is up to 1, right? This goes up to 1. This is 0, this is negative 1, and this is 0, right? It kind of matches this going left to right. So it kind of makes sense if we think about what our graph does. But for now, I would reference our coordinates and remember that y is the sine and x is the cosine. Tangent is a little bit weird, just because it has such a weird looking graph. So I'm just going to kind of fill that in based on where it is with the quadrantal. It's kind of based on that tangent is sine over cosine. Right, so because tangent is sine over cosine, it falls from there, but we're not really up to that yet. So let me just fill in tangent 0, because it's sine over cosine. 0 over 1, that's 0. Tangent is sine over cosine. 1 divided by 0, well, you can't divide by 0, so that's undefined. Right, and then 0 over negative 1, that's just 0. I can't have negative 0. What's negative 1 over 0? Because tangent is sine over cosine. Well, I cannot divide by 0, so I'm undefined. And then what's 0 over 1 again? That's 0. Right, so there's tangent. A little bit harder. I mean, you could look at the graph, but you could look at the unit circle, but I usually just like to look at it as tangent as sine over cosine. If you graph sine, cosine, and tangent, you notice something that happens where my tangent's asymptotes are. Right? If you remember that tangent is sine over cosine, that's where I'm undefined. Those are my asymptotes. Similar. Right? Exactly where my asymptotes are is where I'm undefined. Okay, now cosecant, right, is just the flip of sine. When I flip 0, I can't divide by 0. So that means this is undefined. Cosecant matches with sine. When I flip over sine, I just get 1 over 1. That's 1. If I flip over sine here, I cannot divide, right? 0 over 1. If I flip that, I get undefined. Right? I look here, I can flip sine over there, and I just get negative 1 over 1. And when that flips, I still get negative 1. And then when I have 0 over here, when I flip that, I get undefined again, right? So it kind of matches that cosecant and sine. Wherever there's 0, that's where I'm undefined, because I cannot flip that fraction. I'm going to get something undefined. But wherever I have a 1 or a negative 1, it stays the same. Let's look at secant, which matches with cosine. It's going to be exactly the same. Flip over 1, I get 1. Flip over 0 over 1, and this is really just a 0 over 1. I flip that over, I cannot divide by 0, so that's undefined. Negative 1, same idea. I cannot flip that over. I can flip that over, and I get negative 1 over 1, which is just negative 1 over 1. 0, I try to flip over 0 over 1, and I just get 1 over 0, which we cannot divide by 0, so that's undefined. I flip over 1, and I get 1 over 1, which is 1, right? So if we understand our relations of trig functions, it makes this a little bit easier. And a lot of it's based on our coordinates, which is with our unit circle, and then understanding what maps with what. Right? Sine and cosine, we did those based on the coordinates. Secant and cosecant, we did those based on reciprocating, or flipping these. Tangent, we looked at as the reference of sine over cosine, so like the division of sine over the division of cosine. Right? And I'll just show a little bit of, I like to show this, tangent, right, is opposite over adjacent. If I write sine over cosine, and I write sine as opposite over hypotenuse, and cosine is adjacent over hypotenuse, fraction over fraction, keep, change, flip, cancel out my h's, and I get O over A, and that's tangent. So this is kind of why. This is the reason why tangent is opposite over adjacent, and also known as sine over cosine, because my hypotenuses will cancel out. Interesting thing, I like to show that. All right, now cotangent is the flip of tangent. Again, gets a little bit weird. Whenever there's a 0, which is really just 0 over 1, we cannot divide by 0, so those are my undefined ones. Right, and then I have 0 here, so that's undefined, and then I have 0 here, so that's undefined. Now with these, it's getting a little weird, right? This is undefined because it was 1 over 0. If I flip that, I get 0 over 1. So that means cotangent 0. A little bit weird here. I understand tangent and cotangent a little bit weird. And again, cotangent is, instead of sine over cosine, it's cosine over sine. 0 over -1, that's 0. Right, so sine and cosine a little bit weird because I have this alternating in 0 and undefined at my quadrantals. Not the prettiest thing. Sine and cosine, very nice. Very, very nice. And that's most often what we'll see. To get the reciprocals, we have to understand the flipping of sine over cosine, right? So really, sine and cosine are my basis for a lot of this. Okay, so that was the last part of that. We just wanted to make sure we understood cofunctions, which hopefully we do. They're complementary. Make sure we understood our chart here with quadrantals, and then we'll just do some practice with some radians, and then we're gonna probably have some sort of an assessment next class. Okay, so if we look down here, there's classwork A and B, right? Use the following functions, cofunctions, to write an equivalent expression. They must add up to 90, so you may have to switch some of these to degrees, just as we saw. Calculate the following trig functions. Some of these are quadrantals, and some of them are just normal. You graph it. All students take calculus, and you find your value. But some of them are quadrantals, so it's a little bit of a review of everything. Good luck, and we'll see you on Wednesday.